Welcome to the Roniel and DaRon podcast show. I'm DaRon.
And I'm Roniel.
So, in today's episode, I'd like if we can maybe compare and contrast the job of a scientist versus an engineer. And
Which Ron is both.
yes, I am actually both. And I think that's actually one of the important things is, I'll be honest with you, the distinctions are largely arbitrary. There's so much overlap between the two.
And if you haven't already, get you some Wawa, some smart water. Definitely keep you hydrated. And so you won't have any chokes or any issues while you're talking. This is good water to keep you hydrated. Help us.
You don't want to sound like me sometimes, you know?
Good one.
So I think one of the things maybe we should start off with is a definition of engineer. So as a classically trained engineer with an engineering degree, I'll let you give it a go. So what do you see an engineer doing? What defines what makes someone an engineer?
Okay, well, I mean, it's depending on what type of engineer but engineering to me is a design thing. Um, you know, that's always been my thing that I was taught. An engineer, because it was a difference between a technician and an engineer. What separated the two is one could test and repair, and the other one could design. You didn't have that specification if you were a technician. You could not design a circuit board or design whatever it may be, depending on what type of engineering you're in. But basically, in my perspective, somebody as an engineer is going to be able to design things. And in cases of a technician, you're not going to be able to. I'm not saying you can't. There are technicians. I am a tech. I had been a tech engineering technician. I've also been an engineer, and as a technician, you can still design shit. But that's supposed to be the definition. And if we want to get broader, it could be a broader term of engineering. But what I'm saying in Lame's term, the whole thing with an engineer is you're supposed to be able to design and create things. As a technician, you will not be. You'll probably be repairing those things and taking those boards and going off of the design that they already have and creating it for them. So, I mean, I don't know what your thoughts is about it, but that's been my whole. Ever since I was an engineer, I was designing circuit board specifications for a technician to actually take and create for me. So, know what your thoughts is.
Yeah, I think that's pretty similar. So to me, your engineers largely focus on that architecture and design of a thing. And some engineers physically put these designs, physically implement these designs. I was going to say them to practice, but physically implement these designs. And others stay high level and mostly just work on the designs. That's usually what happens as you climb the ladder and make it through. You stop having to actually do the grunt work, so to speak, and you create these designs and then you throw them over the fence. And I think it's important to recognize that because that's going to make it much easier to see the distinction in general between your scientist versus your engineer. And typically your engineers, they're using already established principles and processes, oftentimes largely established theories and techniques as well. And scientists run a different route. So scientists oftentimes are working on extending existing principles and techniques in a far greater capacity than what your engineers do. Your engineers may push the boundaries a little bit, but your scientists generally are trying to really, they take a question and they try to explore it and see if they can expand upon the body of knowledge, existing body of knowledge, or if they can maybe answer the question such as it may be. And it's not exactly two different perspectives,
It's
but
not, but
please, no, please.
now I was gonna say it's not, but if as you were saying, that I'm as an engineer, I'm going to use, if you're the scientist, I'm going to use what you've already
Right.
theorized
That's
and then
exactly
take
right.
that to solve a problem. So we, as engineers, we use math and science to solve our problems
Right.
that's already been that's theoretical or
Right.
already been proven. So there, you're you're barely going to, come up with any new. I mean, they come up with innovations, but not when it comes to a science perspective.
Yes.
It may be the new innovation of how we create things, like how we got our phone.
Yes.
Right? There was already proof and stuff out there, and all we did as engineers is take that and use it to build what we have now.
Yes.
So
That's
that's just
exactly
going off
right.
what you said. My bad.
No, that's exactly right. That's exactly right. So in general, the way we look at it and the way we think of it is your scientists are creating new techniques and ideas, completely new. They're creating new principles. They're creating new fundamental truths, so to speak. And then your engineers are putting those things to practice to build something. And it could be build the next propulsion system that a scientist created, or it can be to build the various antennae that will be used for deep space communication, or maybe it's something far less, I guess, as far as society seems, to take it far less intricate, something like designing a road system, which, by the way, is complicated, very complicated. Infrastructure, when done right, with an actual engineer applying scientific and mathematical principles, is complicated. This is partially why most cities have such horrible traffic.
Yeah, it's funny you say that, because this whole term, and the reason why we're talking about science, this whole term is, it's crazy because there's always been a fight about which one was better.
Right,
You can't have one without the other.
right.
All right. So my thing is that being an engineer is, it's awesome, but again, scientists are the one that comes up with the proofs and all of the things that we follow today, the methods and how we solve problems. Even in computer science, there's some ways and things that even as a computer scientist, we're supposed to be the ones that are coming up with better ways to solve the programming problem, whatever that may be. Like, how do we program is just a tool that we use to solve a problem, whatever that may be. So the same idea, but with this being said, it has to come to the term of scientist, or actually, before I go to scientist versus engineer, let's go into the term of the subsection of engineering itself. As I was starting to be, go into the field of engineering, it's what I wanted to be, an engineer, before I became a so-called hacker. I was really interested in computer engineering, but at the same time, when I started learning what computer engineering, pretty much like a subset of electrical engineering and
Yeah.
computer science, but all I got one from it, and maybe Ron, you could tell me, but all I got from it is that I would be creating or messing and monkeying around, uh, you know, processors and semiconductors and all this other shit, majority of the time, and it didn't seem like something that was very interesting to work on.
So I worked on a project. We were developing engines. We decided we would use artificial intelligence as part of this. Now, this is going to get a touch on a couple of different things, scientist versus engineer, and a few other things. Now, the artificial intelligence software most people wind up using tends to have at least a basis in Python. Many of the libraries are Python libraries. If you know nothing else, I will tell you Python is a terrible language to write artificial intelligence or machine learning in. Python does not do it well, and it doesn't do it right. There are much better languages that were strictly specifically designed for this. You might as well be writing in Java for your machine learning or artificial intelligence, as far as I'm concerned. And that's foregoing all of the memory issues and the horrible speed that you're going to get using something like Python. But so we're developing engines, big engines, huge engines, jet engines, and rockets. And as part of this, the goal was to maximize the engine such that it uses minimum fuel. Okay? Seems pretty straightforward. So we created a bunch of machine language programs that would help us just quickly iterate over a number of different designs and developments. And it was not well written or configured. And part of that is because scientists help write some of the applications. Scientists who are classical scientists and not computer scientists. And they're not engineers or anything like that. These guys very good at what they do. Writing applications is not one of those things. Okay. In the end, what came of this is and it was mostly computer engineers who helped integrate all of this stuff and write all this. They created an application that determined if you reverse the engines, that it would create fuel. So when all the tests were done, we had engines that literally created fuel. Why? Because it sent the aircraft and spacecraft going backwards. And I've heard a similar story from another major organization, a major aircraft manufacturer, where they had something similar happen. And a large part of it was because the engineers didn't properly bound the problem. Now, you could say, well, this was just an instance of these particular individuals, and that's a perfectly fair argument. But I think it is important to note that for a lot of computer engineer classes, the degree doesn't go deep enough in the various subjects to give you that solid foundation, at least not the ones I've seen. Then I'm sure there are probably some schools out there that do it right, and it's gorgeous. Beautiful. But I think electrical engineering, if what you really want to do is something like what computer engineering is attempting to do, electrical engineering is probably the better choice. Or a good computer science program, with the two being equivalent. It will give you a lot more freedom, but it also gives you that breadth and depth. And this is something that I tell people all the time. So when you initially start out in a field, what you usually want is breadth. And this is similar to military conquest. So if we're doing an invasion, for example, and you see this in things like Normandy, etc., when you land on the beaches, you want a very long front initially. Now, the next thing you need to do is concentrate your forces and then push down. So we go from very wide to very deep, and then we break out going wide again and deep and wide, deep and wide. It's kind of like a reverse Christmas tree design is what it looks like. So it'd be if you looked at a Christmas tree but upside down. That is what you ultimately want from an educational perspective. And I just fear that computer engineering is too watered down in general to fit the bill. So people don't understand basic things like thinking through the use cases and thinking through, okay, well, if this thing is trying to create the optimal design, what are some things I don't want it to do? Flip my engines, because if it flips my engines, I'm either going to go into the ground, which won't be a great thing, or I'm going to go backwards and run off the runway or what have you. Was this just an isolated incident? Unfortunately, no. At least not for me anyway.
Are
But
you saying that electronic engineers suck too? Oh man.
you
Jesus.
guys suck for different reasons.
Hey. I'm an electronic engineer, and I don't know what you're talking about.
That's why
But
you
I
can't
will.
hack.
What? What? You got the wrong guy. You must be talking about Fish Boy,
Oh yeah. Yeah, you
who
can't.
thinks
Yeah.
he has a software engineer degree. No, I would just say that if you really think about it, when I look at electronic and electrical engineering degrees, the program, they're pretty much the same goddamn thing. You might as well just got an electrical
Yeah.
engineering degree because I pretty much did circuit design. That's from digital circuits, then the ACs and
Right.
all that shit all the way down, and then PLCs and multi controllers and FPGAs and stuff like that. PODs, like all those things I've already did in there, and you're kind of going to do that in electrical engineering anyway. But
Yes.
the really good thing about it is if you basically, if I'm doing a subset, that means I'm specializing in one particular thing. In electrical engineering, you can do a multitude of things. You learn
Yes.
about a multitude of things, and if you subset and do just one thing, you're specializing and you're hindering yourself because you're only specialized in that one particular area. Whereas if you're in something like say like computer science or electrical engineering, you kind of have a multitude of things you learn. So
Yes. You're also less pigeonholed as a result. And I think that's really important here. So when you are looking at a college degree, what you need to do, my honest biggest advice is beyond, of course, looking at something that you're passionate about, something that you really like, that it really gets your fires going, is that you sit there and you ask yourself, how well is this degree known? And what is its reputation? Is it seen as a degree that won't get me anywhere? Easy example, communications majors. Everyone laughs about communications majors, mostly because you had a lot of athletes that were using it so that they could get fluff credits and get a degree and all that good stuff because this sports team or that sports team required them to have a degree. So, is what you're going after something that's oftentimes mocked and derided? Is something that you're going after something that's obscure and not well known? Computer engineering, electronic engineering, and then ask yourself, if the answer to that is yes, is there a degree that's a little better known that covers the same general thing? Or that lets me go into whatever the field is that I actually want to go into. And then the other thing I would look at is, do they have a good program? Because the truth is, if you have a bad computer science program, a computer engineering program may very well be for that university the better route. Not likely, but it might be. An electrical engineering degree may be the better route for you for that university. I would try to match my university to what it is I'm after.
electrical engineers get paid more. I just want to be known. Okay.
And
So
that's true. And you should pay attention to that too.
yeah, I'm not saying go for the pay, but I'm
No.
just be truly honest. Like I didn't know about this, and before, and we're giving you pretty much good game, so mouthful of game because I didn't know about this. Like I said, I wanted to do robotics. That was my interest, and I love robots. I love building them. That is my interest, and it was some bullshit called robotic mechanic or electromagnetic some shit, and I was like, I've never heard of that, and I didn't want to do it. So, long and behold, I really wasn't interested because when I was talking to people that were electrical engineers, they dealt with things or did things that I didn't want to do. So I didn't know that I could still take that engineering degree and do other things because there are people who are electrical engineers that do software design. There's people who do a lot of different shit and they're good
Yes.
at it. They're even better than most of the. I'm not saying you in particular. I'm saying a lot of science degree cannot program a lick of shit
Oh,
versus
yeah.
electrical engineers. They're
Mm-hmm.
they're insanely good. So my thing is that if I would have known that before, I would have never had wanted to subset for computer engineering and electronic engineering. So those are the things that I kind of went into.
Well, and to that point, you're right. And part of the reason why you'll get a lot of computer scientists who are particularly, uh, well, bad at their job is because they have no interest, but also because they were light on the hardware side of computer science. Some programs let you have hardly any hardware classes and tied to that operating system classes. And you can't write solid code if you don't understand the way the hardware and the operating system, which both of which are controlling it, operate and how they will handle that. And that goes to some of the arguments and fights we had with people at Highland, for example. You had a lot of people who did not understand the way Itanium works, for example, and they did not understand the way C# works in an Itanium environment, and how, because of the difference as compared to, say, an x64-bit environment, because of that difference, you get race conditions using the programmatical structures that they're using. But that's the kind of stuff they should have learned in computer science, but it's also the kind of stuff that they would have learned in a good computer engineering, sorry, not computer engineering, in a good electrical engineering class. And that, I think, is the kind of stuff that you generally will miss from some of these more obscure degree programs. But like you said, the obscure ones also tend to get paid less. Your electronic engineer versus your electrical engineer, and a large part of that is because they're just not well known. The employers don't know what this degree gives you.
I'll tell you this just from experience. Let me give you. I'm gonna go from your point of view, what you just said, and then on the electronic thing. So, uh, one about how the language works with different architectures. Um, People don't know that, and if
Yeah.
you haven't, then they don't teach you that. Let me be honest. I went to several different schools for engineering, and they don't even teach. They'll teach you about the different architecture, but because they're not heavily focused in security, you won't even know that depending on what language you use, it could be a problematic for that architecture, which could be, like you said, race conditions. You
Yes.
can have that issue because that's what you're supposed to learn
Yes.
when you're setting up. That's why they say that's why are there software engineers if we don't know, or software architects, when you're putting together, hey, we're going to use this language for this architecture, and this will be better because we're going to have issues with this down the line.
Right.
They're supposed to know that stuff. That's why you have architectures and all this other shit. They're supposed to know that you're going to run into these issues, but they also don't have the security, designed by, it's not in there. You don't learn that in school. I don't even think half of these people know that. If I go back and I had started my master's degree, which I was thinking about doing my master's degree in electrical engineering one time, and then I was like, if I go back, I can tell you that if I asked this question, they would not be able to give it to me, and it sucks. But you should know that.
Yes.
But even some of the, like, even in case, they don't teach that. I was at one of their engineering programs. They don't teach certain things, but they do talk about architecture. But even in there, they don't really get into the issues that overlaps with these. So that's just one thing. Now, uh, from an electronic engineering perspective, they pay you like shit. That's the reason why I got out of it. It is a very known thing, but it's not very broad for the bigger companies. Uh,
Yes.
so they look at people with electrical engineering. They still have computer engineering on the degree, but a lot of them are electrical engineers. That's what the first thing you see is electrical engineering or computer science. And electronic engineering, you're pretty much may become pretty much a repair guy. That's kind of what I became, like a repair person. And if I became an engineer, it was either a computer engineer or it would be an electrical engineer, even though I didn't do anything with electrical engineering. But because electronics is a subset of electrical engineering, it's the same shit, except that you don't learn some of the bigger things that you would learn in electrical. But when you're talking about working with circuit boards, I could do that. That's the same shit you learn in electronics. But
Right.
since it's a subset and you can't do all those other things you could as an electrical engineer, it's like a whole 10 times, 20 times less. I'm talking about $8 an hour for the skill. And I'm not saying that and trust me, being an electronic engineer, you have to know a lot of stuff, and you can do a lot of stuff. I can build mechanical and robotic arms. I could do all of that stuff, but you don't have all of that. They don't know you have all the skill sets, so they only look at you as a person that gets parts, repair the parts, and then build the circuit board, solder them, do all that repairing any broken parts. That
Right.
I might as well become a repair guy at the local TV shop.
Right.
Compare all electronic. That sucks. It's like being a computer technician. It's a joke. But don't get me wrong. For all my electronic, it's pretty good field or whatever, pretty decent for what you know, but it's not really good pay. That was the reason why I got out of it, because it wasn't a good pay. And I was like, it's either computer science or electrical engineering. It would have took me 6 to 7 years to get my electrical engineering degree, because I had to start all over again. And it only took me 5 years to get my computer science. It would have been less than that, but I still had to start over again. But I felt that computer science would give me the basis that I needed for what I wanted to do.
Yes.
Foundation. So either route I could have went, but I knew that at the end of the day, if you look at the job perspective, when people are hiring, they're going to hire me more electrical engineering jobs than I wanted. And in the computer science, I could do more of everything, software engineering, computer engineering. I mean,
Yes.
all these different things I could do if I want. But that's just a tip to what DaRon was saying, that be careful for what you choose. Choose something that is that is more known and has a variety of options that can give you
Right.
options of what field you can jump into.
Right.
Like looking for that. So.
Right. Right. And this is similar to like we've talked about before. If you get a bachelor's, that increases your so the order goes: high school degree increases jobs just a little bit, job prospects. AA or any kind of associate's degree increases it actually substantially. A bachelor's increases it much more. A master's increases it a bit, but not too much. And then a PhD, guess what it does?
Shrinks, yeah.
Yep. So PhD is actually worse than picking a degree that is obscure, a program that is obscure. But if it's something you're really into and for whatever reason they require it and you can see yourself doing it all your life, PhD is fine. I would not get a PhD unless you know what you're getting yourself into, because your job prospects will go from ridiculously wide to insanely narrow.
Yeah, because everybody's gonna, first, you overqualified.
Mm-hmm.
Two, you are specialized in a particular thing, so you're gonna be only picked for what you're specialized in. So yeah, that's even worse. At least with electronic engineering degree, I could still do whatever. Like I get jobs all the time for engineering, electrical engineering, field engineering, which is still the electrical engineering, but they call it field engineering. All these different jobs I can do, period. So, I mean, yeah, pretty much.
Yeah.
Pick the right thing that is more known by. You can go look at the resumes. You can go look at job postings out there, and you can see what are the most known degrees to get.
Yes.
It doesn't matter whether you're a scientist or engineer. There's this big thing. This is just giving you the idea what scientists versus engineer are. Some scientists think they're better than engineers. Some engineers think they're better than scientists. But to me, you can't have one and out the other.
Yes.
So
yes.
It doesn't really matter which one you are, because at the end of the day, you can be an engineer and still become a scientist.
Yes. What good is an understanding of a heliocentric solar system if you're not going to do anything with it?
Right. This is another reason why I didn't become a physicist, because I couldn't do it. Like, I mean, you're not going to get a job either.
No.
Pay good money.
Yes, that's true. And that's actually important, is a lot of those degrees, physics, math is a funny one. The jobs you can get are so distinct from one another that it makes it very hard to transition from one to the other despite having the degree. And physics puts you in a very narrow gap. So you really do need to be cognizant of that kind of stuff. may wind up hosing you in the end. I know people who made bad choices in their degrees and they can't find a job. Getting a degree in journalism is awesome, except there are no journalist jobs anymore. There are so few. The fighting is so ferocious. It's ridiculously hard to get one. Getting a degree in paleontology is fantastic. That's neat, but it's a PhD program. So, I mean, you're going to have to go through and get a bachelor's and then either get a master's or skip the master's. Remember, you do not have to have a master's to get a PhD, but then move into that PhD, and that's a lengthy commitment. And the job prospects for someone with a paleontology degree so incredibly narrow. So narrow, and they don't even pay that well. Now, pay is not the end of the universe, but you do have to factor it in, because if you like nice things, then maybe don't take a job or get a degree in something that just doesn't pay.
So if you want to be a scientist, the biggest thing I guess to say would make the most money is become a doctor. How about that?
Become a doctor. Oh, I'm sorry, please.
No, go ahead. I was just going to say, become a doctor and pick those fields that, doctors may want to specialize in, whatever that may be. But at least you're still a scientist and you're making a good amount of money. Or I don't want to say this, you could become an engineer or a computer scientist, which everybody's going to debate that computer science is not science, or not a scientist, or you're not a scientist. So I don't know. But regardless of what your debate is, it's still a science. It still says computer science. And regardless of whether you want to compare whether the scientists, there are actually computer scientist jobs out there. So
there are.
Whatever. That's like debating, is data science a science?
Yes. Well, I will say neuroscience isn't a science and social sciences aren't sciences. But other than that, yeah, computer science is a science. Yep. Geology is a joke.
We're definitely going to have to talk about that when we get off. Anyway, so yes, get your computer science degree, get your electrical engineering degree, get your doctor as a doctor, not an MD or something, not a PhD. And other than that, I mean, this is our time. I'm Roniel.
I'm DaRon.
And if you haven't already, please comment, like, subscribe, explain us about scientists and versus engineers. If you have any computer engineering, whatever the hell, also get you some Wawa, some smart water. Smart water, you guys are gonna have to start sponsoring us in the other waters, but stay hydrated. Until then, this is our time.
We'll go to the competition if you don't.
Later.
Have fun.